Hello dear students, today we will discuss about the vectors, the topic from two-dimensional motion from grade 11th. So it's very interesting, also very important topic of physics for grade 11th as well as for 12th also, because many topics are there in 12th standard which are based on vectors. So the basic knowledge of vector is very important for the grade 11th student, for the 12th purpose also. Coming to the what is actually vectors, what is vector quantity and what is scalar quantity. So first I'm explaining the scalar quantity. Actually physical quantities are classified into two groups. Physical quantities are classified into two groups. One is the scalar quantity and the second group is the vector quantity. So first, what is scalar and what is vector? What is the difference between scalar and vector, right? So scalar quantity, the quantities which require only magnitude for their complete representation. I am repeating, the quantities which require only magnitude for their complete representation are called the scalar quantities, right? Suppose I am trying to write mass, right? So suppose mass of any body is 2 kg. So if I am writing 2 kg, then it's complete, right? No requirement of writing direction because it's a scalar quantity. So the scalar quantity is what? The scalar quantity, the definition is the quantity which require only magnitude for its representation, or I must say complete representation, then this is called the scalar quantity, right? Now coming to the vector. So vector quantity is what? The quantities, this one, vector quantities, the quantities which require magnitude as well as direction for their complete representation. I am repeating, if any quantity, physical quantity require magnitude as well as direction for its complete representation, then we will say that particular quantity is vector quantity. For example, I am taking one example of that, suppose force is there, right? So if we want to write force, then if I am writing 2 Newton, it's not correct actually. Why? Because 2 Newton should be specified by the direction, whether it is acting towards north, it is acting towards south, it is acting upward or it is acting downward or in any particular direction. So the physical quantities which require magnitude as well as direction for their complete representation, these physical quantities are called the vector quantities. So the scalar quantities do not require any kind of direction for their complete representation, while the vector quantities require magnitude as well as direction for their complete representation. So the definitions are there, I told you. General vector notation, how can we a vector quantity represent? What is the representation of a vector quantity? A vector quantity is simply represented by an arrow, right? Arrow, the end point or the tail of that arrow will show you the starting point of that particular vector, and head of the arrow will give you the direction of that particular quantity. I am giving you for example, suppose I am representing any quantity like I am writing 2 Newton in terms of vector. This is the force. So examples of vector quantities are force, acceleration. These are the examples. Force, acceleration, displacement, etc. These are the examples of vector quantity. So if we want to write or represent any vector quantity, so it is simply represented by an arrow, right? This is the arrow. The head of this arrow will tell you the direction. This is called the head of the arrow, right? So head will tell you the direction, and this tail will tell you the starting point. Starting point, right? Head will tell you the direction, and tail will tell you the starting point of that particular quantity, physical quantity. And also the length of the arrow, this one, from here to here, will tell you the length. Suppose this is A and this one is B. So the AB, length AB will give you the magnitude of vector. It will give you magnitude of vector quantity. So what I told you, the vector is represented by an arrow, this one, and the direction of this arrow, that means head, will give you the direction of that particular vector. Tail of the arrow will give you the starting point of the vector, and the length of this arrow will give you the magnitude of vector. Right? I'm giving you another example. Like this is the vector, any vector A and B. Suppose the length of this is 2 meter and scale is 1 meter is equal to 1 Newton is the scale. So the 2 meter length means the force is 2 Newton, and suppose I am marking the directions. So this is east, west, north and south. Then we will say this is the vector of magnitude 2 Newton acting towards east, because the direction of this vector is along east. So this is the representation of a vector quantity. This is the representation of any vector quantity. Now I have given you many examples of that. Now participation of vector quantities. How many classes of vectors are there? How can we classify the vector in different parts or groups? So the base of classification of vector is the direction of the vectors. If we want to represent any vector in a specific direction, then on the basis of this direction, it is classified into